Hello and welcome to the 8th video of my Left 4 Dead 2 mapping tutorial series. This video will be going over the input and output system. This system is very important to learn and may get complex at times, so pay attention. The input-output system, or the I/O system, allows you to create dynamic levels that interact and react with the player. It's absolutely necessary to learn this system when making a Left 4 Dead 2 map to create crescendo events and finales. Along with anything else, you want to be dynamic and reactive. The I/O system is used in all Left 4 Dead 2 maps. A couple examples are starting the car in Dead Air to make the van move and summon a horde, and hitting the test of strength machine in Dark Carnival. The name of this system itself refers to the medium in which entities can communicate with each other within a map. An entity can have an output, and when the output's conditions are met, the entity sends commands to another entity, telling that second entity to do something. This is also referred to as the output being fired. The second entity receives the commands as an input and carries out whatever the input requests. Almost all entities can send outputs to other entities. It's best to learn this system by jumping in with a simple example. Here's a doorway and a door made out of a brush. We can make a brush-based door by turning the brush door into a func_door entity. There are a lot of parameters here. You can change the speed of the door, the sound it makes, the delay before closing again, the direction it moves, etc. Let's change the direction to move up. Go to the flags tab and turn off touch opens. If we want any entity to receive inputs, we need to give it a name. A name can be anything, but for relevancy, let's just name the door door. We can make the door open automatically when we get close to it by using a trigger brush entity. Make a new brush with the tools trigger texture nearby the door. Turn it into a trigger_once entity with Ctrl+T. This entity can be used to trigger outputs to be sent out whenever a player touches it. Go to flags and make sure clients is checked. Now, go to the outputs tab. This is the tab where all the magic happens. Hit add to create a new output. Click on the drop down arrow next to the line that says my output named. This shows a list of outputs you can choose from. For the trigger_once entity, you'll mainly want to use onTrigger, which fires whenever someone touches the door. Next, select the drop down arrow on the line that says target entities named. This line directs the output to fire instructions at a certain entity. Door should pop up, click it. Now click the drop down arrow on the line that says via this input. This line is what instructions you send off to the target entity. In this case, we're sending instructions to a door and we want it to open, so we'll simply click open. We can also add a delay to the output being fired, along with telling the output to only be fired once if desired. When you're all done, hit apply at the bottom right. Open the door's properties and go to the inputs tab. We can see instructions it receives from the trigger. You can't do anything in this tab, only see instructions this entity receives. Great if you're trying to reverse engineer some complicated logic. Let's compile and see it work in game. Great, the door opens when we touch the trigger, and it closes automatically. But we try to do it again and it doesn't work. That's because we used a trigger_once entity, which, as the name implies, triggers once and never again. We can have a trigger work more than once by using a trigger_multiple. Let's simply change the trigger_once's class into a trigger_multiple. What allows trigger multiple to work is this delay before reset parameter here. Once it's triggered, it will use this delay before it can be triggered again. In game, we can repeatedly open the door, but if we stand in the trigger, it awkwardly opens and closes, because the door entity closes on its own. If we set delay before reset on the door to -1, it will never close again by itself. What if we want it to close again though, say after the player leaves the trigger? Well, we can tell the trigger_multiple to fire outputs while a player continuously stands in it, like holding open the door. Let's change the output from onTrigger to onStartTouchAll. Now let's add a second output to close the door when the player leaves the trigger. Click add to create a new output, select onEndTouchAll as the output named, target the door and tell it to close. Let's add a delay to the door closing so that it doesn't shut in people's faces. 3 seconds sounds good. In game, the door stays open for us and closes when we leave the trigger, exactly what we wanted. A thing to keep in mind with triggers is that special infected can actually trigger them. If you're making a trigger meant only for survivors, then you'd have to use what's called a filter_activator_team entity. As the name implies, it checks to see if the activator is on the correct team. Place one down and open its properties. Name it filter_survivors. The two options by default are exactly what we want, so we'll leave them. Now in a trigger entity's properties, look for the filter name parameter, click the drop down and select the filter. Only survivors can activate this now. Instead of using triggers, let's use a button. Make a new brush with whatever texture you want. and turn it into a func underscore button entity with control plus T. Lots of options here, but I'll leave it on default and add back the output to tell the door to open. Add a new output, use on press, which fires when the button is pressed. Then target the door and tell it to open. In game, trigger the button by using your use key, which is likely E. By default, the button moves when pressed and resets back after a delay. We can make a much more elegant button with the use of a prop underscore dynamic. We need to use prop dynamic because prop static can't be used with the IO system. Place one down and choose a model, preferably one with animations. You can see which models have animations by checking the sequences tab in the model browser. I'll use freight elevator button 01. Name the prop button model and set its default animation to the animation that represents it being off. Scale the func button entity to match the button model. I will also change the texture to tools trigger to see the button model inside it. In the func underscore buttons properties, set the render mode to don't render, so we don't see the trigger texture in game. Go to flags and check the don't move flag. We want the button model to be animated when pressed, so add a new output. On pressed, target button model, set animation with a parameter override of turn underscore on. This parameter override line is usually grayed out, but here it becomes available because we used the set animation input, which requires a further parameter be sent along with the input. For set animation, the parameter override tells the target entity what animation to play. Next, with the output we just made selected, click copy and paste at the bottom to duplicate it. Change set animation to set default animation with a parameter override of idle on. This sets the idle on animation for the button model as default, meaning it will play right after turn underscore on is finished. Additionally, we can make the button model glow when we get close by going to the class info panel and setting button model as the glow entity. Right below that is sounds. Pick any sound you want. Let's compile and check all this out in game. It all works and looks pretty, but when the door automatically goes back down, the button doesn't change to reflect that. Let's add an output from the door to the button model. Click add, on close, target button model, set default animation to idle off. Copy and paste that output and change set default animation to set animation. We can also change the button to be locked after pressing and unlock when the door closes. But before we do that, we need to give the func underscore button a name so that it can receive inputs. Let's name it button. In the outputs tab for the func button, make a new output on pressed with a target of !self with the input of lock. !self is whatever entity this output originates from, so the func button itself. Next, in the outputs tab for the door, make a new output on fully closed, target the button, via the input unlock. In game, the button model returns to its idle off animation and we can't interact with it until the door goes down. Left 4 Dead 2 has another style of buttons that make use of the timer system seen when reviving or healing. It's called func underscore button underscore timed. Let's change this func underscore button to a func underscore button underscore timed. There are new properties here. Use time is how long it takes for the button to finish. Use string is the text that sits on top of the timer bar, and use substring is text that sits below the timer bar. Things have changed in the outputs tab. The on pressed output now works when the button is first interacted with, not when its timer is depleted. The output on time up is what actually fires when the timer is depleted, which is what we want. Instead of opening a door, let's make a button to break a wall. I have a section of a wall I want to break, so I'll turn it into a func underscore breakable entity. This entity is what the name implies. It's a brush that can be broken and shoots gibs everywhere when it breaks. Name it wall. Change the material type to whatever is appropriate. In the flags tab, check the only break on trigger flag and hit apply. I have the same button and button model set up as before, but I'll change the delay before reset property to -1 because we won't need to press it again. For the func buttons outputs, I'll make a new one on pressed, target the func underscore breakable, and set the input to break. I'll put a delay of 2 seconds for added tension. Everything is interchangeable. I used a button here to break this wall, but you can use a trigger, or you can use the button or trigger to open the door, or to do something else, or use anything to do anything. I'll be going into a bit more complex stuff from this point onwards, and I'll be less direct with explaining. Hopefully you understand the gist of the system by now. If not, it'll click soon enough. Logic underscore timer can be used to fire outputs on a repeated timer. We can use this entity to make a flickering light, for example. I have this small room with a light underscore spot and an accompanying prop dynamic. This model, light underscore shop.mdl, has skins, different materials you can use for the model. In this case, the model has 2 skins that represent the light being on and off. Underneath is the logic underscore timer entity. In the timer's properties is the refire interval option to make the timer fire after a consistent delay. It's set to 1, meaning it repeatedly fires all of its outputs every 1 second. In the outputs tab, they all start with on timer, the output that fires when the timer reaches 0. The first 2 tell the light to turn off and to set the light model's skin to 1, which represents the light being off. The second 2 have a delay of 0.5 or half a second, and they turn the light back on and set the skin back to 0, which represents it being on. Because of our logic timer's refire delay set to 1 second, the first half of the second the light will be off, the second half the light will be on. Let's hop in game and see how this looks. It turns on and off every half second, and the light model matches. We can make the light randomly flicker by opening the timer's properties, removing the refire interval value, and setting use random time to yes. Next, put in values for the minimum and maximum random interval parameters. These are pretty obvious. They set the time window that the timer can randomly fire in. I'll use 0.5 for the minimum and 2 for the maximum. In the outputs tab, let's change the turn on and skin 0 outputs to a delay of 0.25, less than the minimum random interval we set. Now in game, sometimes the light flickers fast and sometimes it takes a second. Logic_relay is a really handy tool when used correctly. It can be used to simplify complicated outputs or it can be used to break input-output chains. Logic relay can hold many outputs within itself and multiple things that can call upon it to fire all the same outputs. In this map, I have a logic relay that has 2 outputs to turn on and off the light and make the model animate. To trigger the relay, there's a trigger_multiple and a func_ button. Both of these have outputs to simply tell the logic relay to fire its outputs with the trigger input. In game, I can use both methods of triggering the logic relay to send the same outputs, rather than making multiple outputs for the trigger and button. Now earlier I said logic relay can be used to break input-output chains. What this means is that we can kill or disable the logic relay with some other entity's output to prevent the logic relay from firing its outputs. Luckily for us, I can easily demonstrate by using the ent_fire console command. This console command allows us to fire outputs to things while we're in game, useful for testing purposes. Open the console and type ent_fire, then look for the logic_relay's name and type it in, followed by disable. Now the trigger and button don't do anything. That's because the logic relay is disabled. Let's turn it back on by repeating that console command, but changing disable to enable. It works again. Next, let's get into the logic_case entity. This entity can do many complex things, like pick random outputs or be sent values and compare to fire appropriate outputs. Randomizing outputs is by far the most common use case for this entity, so we'll go over that first. Here's an example map I made. I have 2 info_zombie_spawn entities here. These entities allow you to spawn zombies manually if you so desire. I have a logic_case here with nothing added in the class info panel but a name. The logic case has 2 outputs. On case 01, spawn the left zombie. On case 02, spawn the right zombie. Finally, I have a button that tells the logic case to pick any random on-case output with a pick random input. More specifically, it will choose a case, like 1, and then fire all the outputs with on case 01. Because logic case only holds 16 potential cases, that means you're limited to 16 random outputs. Let's compile and look at it in game. I press the button and zombies are randomly spawned on each side. Last logic entity we'll go over is the math_counter entity. This entity holds a value within itself, and you can add or subtract that value to fire different outputs. Here's the example map. I have a breakable wall, a math counter entity, and a button. Double clicking on the math counter shows some options. So, the math counter has a value that you can add or subtract. You can set what that value starts at with initial value. You can change the minimum and maximum that this value can reach. Here I have the maximum set to 5. In the outputs tab is an output on hit max, meaning the output will fire when the counter hits the max value. Target the wall and break it. In the outputs tab for the func button, I have an output on pressed. Target the counter via the input add with a parameter of 1. This adds 1 to the counter. So the goal of all this is to make the wall break after pressing the button 5 times. Compiled and in game, it works as expected. But if we look at the outputs for the math_counter, we see that we can only fire outputs when this counter hits max and minimum. What if we wanted to have special outputs for when the counter hits numbers in between? You can use the previously learned logic_case entity in conjunction with math_counter to achieve this. Last example map I'll be showing today. I have lights on the wall, a red light that starts on, a blue light that starts off, and a green light that starts off. Here's 2 buttons. The left adds 1 to the counter, the right subtracts 1 from the counter. The counter has its legal value set from 1 to 5, with the start value being 1. In the outputs for the counter, it has one output, out value, meaning every time the counter's value changes, we fire this output, targeted towards the logic_case, via the input in value, meaning the logic case takes in the current value of the counter to compare. You can also set a parameter for in value, which will make the counter take in whatever number you put. That defeats the purpose of what we're trying to do here, so leave it blank. In the logic case, I have case 01 through 5 listing integers 1 to 5. When the logic case receives a number from the counter, it will compare from these cases and match with the case that has the same number, which we can then use to fire special outputs for each case. Going to the Outputs tab shows all the outputs I have set to fire when the different cases match the received value from the math_counter. The lights turn on and off depending on the value of the counter. Red on 1, nothing on 2, green on 3, nothing on 4, and blue on 5. It may look complicated, but in reality it's simple if you just take your time when analyzing it. This is what we get in game. This concludes the 8th video of my Left 4 Dead 2 mapping tutorial series. I get that this system may be complicated to learn, and even after watching all this you still may be confused. I suggest rewatching earlier parts of this video and experimenting on your own. Soon enough you'll get it. The input and output names are frequently vague and confusing. The Valve developer community is a great resource to get detailed explanations about pretty much everything Source, be that pages for any entities which go over its properties and the aforementioned vague inputs and outputs and more, texturing, modeling, how to design good maps, and more. Every video in this series has the website linked in the description below. Check it out if you need more help. Next video in this series is another big one. We'll be going over director scripts, which we can now utilize thanks to our newfound understanding of the input-output system. Thank you for watching.